Okay, welcome to I Square Maths Academy, where numbers meet mastery. Now, I want us to look at intercepts, or you want to get not just intercepts, the slope. Okay, now we know that our gradient is y2 minus y1 all over x2 minus x1, where here you have your y-axis and here you have your x-axis. So here you have your y2, here you have y1, and here you have the value of x2, and here you have the value of x1. So to calculate for the gradient of tangent here is y2 minus y1 all over x2 minus x1. So that's actually the gradient of tangent. And today I want us to look at the gradients of tangents when dealing with the curve. Now, as you can see, this is a curve and we have a straight line, a tangent. Yes. Now look at this. The gradient of a curve y is equal to f of x at point P, at this point on the curve. Now this is the curve. It is given by the gradient of the tangent at point P. Yes, at this particular point P. So it is also given by the value, the y all over the x. Yes, because the value of the y we all know all over the x is changing y all over changing x, which is the same as y2 minus y1 all over x2 minus x1. So it means that the tangent at P, also given by the value of the y over the x at the point P. We can also calculate knowing the equation of the curve. So it means when we know the equation of this curve, we can calculate for the gradient of tangent and also the gradient of normal, the perpendicular gradient. Now we're going to be looking at some examples. Yes. Now example one. Given the curve x squared y plus 4xy is equal to 8, comma, find the equation of tangents, find the equation of tangent and normal, tangent and normal to the curve. Now this is an example. Now, like we said, when you have the equation of the curve, you can calculate for the gradient of tangent, the gradient of normal, the equation of tangent, and also the equation of normal. Now let's look at this. Yes, here the curve here is x squared y plus 4xy is equal to 8. Now at points, let's say here we have 1, okay, x1 and y1. So now let's look at this. X squared y plus 4xy is equal to 8. Now this is another case of implicit function where the relationship between x and y is much more involved. Now if you look at this very well, this is the product of two functions. Here we have x squared and y, and here we have x and y. So here we are going to differentiating term by term. Now, because this is actually a product of two functions, we are going to apply the product rule. I remember for the product rule, we said if y is equal to uv, that the y all over the x is v d all over the x plus u over v all over the x. So therefore means that here we'll pick our v, which is y. Okay, so here we have y. When you differentiate x squared, it gives 2x. Then here we have plus, you pick your u, which is x squared. Now when you differentiate y, it gives 1. But because we are differentiating with respect to x, it means whenever you differentiate y, you follow it up with the y dx. So it means here we have the y all over the x. Then here we have plus. This is another product of two functions, x, y. So here our v is y and our u is 4x. So now you pick v, which is y, you differentiate u. When you differentiate 4x, it gives 4, plus you pick 4x. Yes, when you differentiate y, you have 1, you follow it with the y all over the x. Now it's equal to. Now, if you look at our right hand side, we have 8. And 8 is constant. And we all know that when you differentiate a constant, it gives you 0. So that implies that here we have 0. Okay, here we have 0. So it means here we have 2xy. Y times 2x is 2xy. Plus, here we have x squared the y all over the x, plus y times 4 is 4y, plus here we have 4x, the y all over the x is equal to 0. Yes, it's equal to 0. So now I want us to take the other functions without the y dx to the other side and leave those functions with the y dx at the left hand side. So it means that x squared, the y all over the x, plus we have 4x, the y all over the x will be equal to, now taking this plus 2xy to the other side, crossing this equality sign, it will change to minus 2xy. And here we have plus 4y. Taking it to the other side will also change to minus 4y. So it means at the left hand side, the y all over the x is common. Yes, we have the y all over the x here. We also have it here. So it means now that when you factor it out, we have the y dx outside in brackets x squared plus 4x is equal to minus 2xy minus 4y. Yes. Now let's get the value of the y all over the x. It means the y all over the x will be equal to minus 2xy minus 4y all over x squared plus 4x. Yes, that's the y all over the x. And remember we said the gradient is also is the same thing as the y all over the x. So it means this is the gradient of the curve. Yes, the gradient of tangent. Now at this point, since we are given 2 points, 1, 1, it means the value of x, we are going to substitute 1, and also the value of y, 1. So it means the gradient of tangent. Now I'm using m. Yes, I'm using m to designate the gradient of tangent. So m now will be equal to minus 2 in bracket, the value of x is 1, the value of y is 1, minus 4, the value of y is 1, all over, here we have 1 squared because x is 1, plus, here we have 4y, please, this is 4y. So we have 4 in brackets 1, because the value of y is also 1. Okay, no, sorry. The value of here we have x, that's this 4x. So this is 1. Okay, now the gradient of tangent. Gradient of tangent, which is m, is equal to minus 2 times 1 times 1. That will give us minus 2. So here we have minus 2 minus, here we have minus 4 times 1. Minus 4 times 1 is minus 4. All over, here we have 1 square. 1 square is 1 times 1. And 1 times 1 is 1. So here we have 1 plus, we have 4 times 1. And 4 times 1 is 4. So it therefore means that the value of our m will be equal to minus 2 minus 4 is minus 6. All over, we have 1 plus 4. 1 plus 4 is equal to 5. So it therefore means that the gradient of tangent is equal to minus 6 all over 5. Now let's look at the gradient of normal. The gradient of normal. Okay, now let's use M1 to represent the gradient of normal. And as we all know from coordinate geometry, that the gradient of tangent times the gradient of normal is equal to minus 1. Yes, I take it again. The gradient of tangent times the gradient of normal is equal to minus 1. So at this point, we have m, and the value of our m is minus 6 all over 5 times m1 is equal to minus 1. So it means the value of our m1 will be equal to minus 1 divided by minus 6 all over 5. So it means minus minus will change to plus, and the reciprocal of 6 over 5 will now change to 5 all over 6. Now, this is the gradient of normal. Now, we have the gradient of tangent. The gradient of tangent is minus 6 over 5, and the gradient of normal is 5 all over 6. Now, let's look at the equation of tangent. Equation of tangent. Yes, equation of tangent. Now, we said here, our y minus y1 is equal to m in bracket x minus x1. Yes, y minus y1 is equal to m in bracket x minus x1. Now, m is the gradient. Y1 is the points given as y, and x1 is that of x. And here we see it here that our x1 is 1, our y1 is 1. It means here we have y minus 1 is equal to m. And our m, the gradient of tangent, is minus 6 over 5. So here we have minus 6 all over 5. Then here we have x minus 1. Because the value of our x1 is also 1. So here we have y minus 1 is equal to minus 6 all over 5 in bracket x minus 1. Now, to remove the fraction, we are going to multiply through by the LCM. And here 5 is the LCM because this is over 1. So we are multiplying through by 5. So we multiply through by 5. We have 5 in bracket y minus 1 is equal to 5 times minus 6 all over 5 in bracket x minus 1. So this 5 will cancel this 5. It means we have 5 in bracket y minus 1 is equal to minus 6 in bracket x minus 1. Now, 5 times y is 5y. 5 times minus 1 is minus 5. And this will be equal to minus 6 times x. That will give us minus 6x. Minus 6 times minus 1. Minus times minus is plus. So here we have 6 times 1 is 6. Now it means bringing those minus 6 to this place, to the left hand side, we have 5y plus 6x will be equal to 6. If you take this minus 5 to the other side, it becomes plus 5. So here we have 5y plus 6x is equal to 11. Now this is the equation of tangent. So here we have seen the gradient of tangent, and we have also seen the equation of tangent. So now we have the equation, the gradient of normal to be 5 all over 6. So I want us to get the equation of normal. Yes, the equation of normal. Now to find the equation of normal, we are going to use the same points. Yes, so we have y minus y1 will be equal to m1 in bracket x minus x1. Yes, when calculating for the equation of tangent, we actually use m because m is the gradient of tangent. But now we are calculating for the equation, we are looking for the equation of normal. And because the gradient of normal is 5 all over 6, that is what we're going to be using here. So we have y minus 1 is equal to, or the gradient of normal is 5 all over 6. So we have 5 over 6 in bracket x minus 1. Now at this point, to remove the fraction, we have to multiply. We multiply through by 6. So multiplying through by 6 implies multiplying both the left hand side and right hand side by 6. It therefore means that for the left hand side, we have 6 in bracket y minus 1 is equal to, for the right hand side, we have 6 in bracket 5 all over 6. Then here we have x minus 1. Now, this 6 will go with this 6. It means here we have 6y minus 6 times y is 6y. 6 times 1 is 6. It's equal to, remember we're left with 5 here. 5 times x is 5x. 5 times minus 1 is minus 5. Now, it means here we have 6y. Taking this 5x to the other side, we have minus 5x is equal to, we have minus 5 there before. Taking minus 6 to the other side, we have plus 6. It therefore means that 6y minus 5x will be equal to minus 5 plus 6 is equal to 1. So this is the equation of normal. Yes, this is the equation of normal to the curve. And here we have the equation of tangent to the curve. Please watch out for more examples, and thank you so much for listening. God bless you.